So, this class I will discuss about the load transfer mechanism of the conduit, and in the last class I have discussed that this is the application areas of the conduit, what are the different types of conduit, ditch conduit, positive projecting conduits, and then negative projecting conduit, and then this is the your impact ditch conduits. Okay. So, now in the that class also I have discussed about the your soil arching theories, and then what is the active arching, what is the passive arching, that I have discussed. Now, this class what I will discuss about the how the load is transferred from this case. Okay. So, first I am considering that in my case that the stress on the conduit should be less, okay, it should be reduced. So, I will consider one case where this is the your narrow backfill or the backfill which is loose. So, this will deform. So, this is the yielding part where this is the ground surface. Okay. So, where we are applying a stress Q. Okay. So, because that is the we will hear that this is the yielding or moving part, and this is the rigid part. Okay. So, this is the rigid part or the non less yielding part, and this is the this side also rigid or less yielding, this is the yielding part. Okay. So, this is the yielding mass. And we can say rigid or stationary mass. Okay. So, I am considering one particular strip. This is the particular strip which is at a depth of h from the ground surface, and the thickness is dz. Okay. So, what is the stresses acting in this strip, or so that in the vertical stress that will act sigma v, okay, and in the bottom this stress will be sigma v plus d sigma v, and the weight of this stress this strip will also act. Okay. W is the weight of this strip, and this side there will be friction or shear, because here this portion is moving and this portion is not moving. So, there will be a friction, and that force is equal to your this is the as I mentioned, because of this movement a shear plane is developed. So, this shear stress or the shear plane, this I can write that C plus sigma h tan phi. Okay. This is again the soil versus soils, that is why I have written the phi. And why sigma h? Because this is the sigma h is acting here. Okay. This is the sigma h, and this sigma h is equal to k into sigma v. Okay. So, finally, if I take this strip, so this will be the sigma v this will be sigma v plus d sigma v, and the weight of the strip will also act, and the here this is sigma h, which is k into sigma v. This is also sigma h, which is k into sigma v. K is the coefficient of earth pressure. So, this value will be your C plus sigma h tan phi, okay. And this side also there will be stress, this is C sigma h tan phi, this is the shear plane. So, and this thickness of this or the width of this trench is 2b. Okay. So, now finally, if I take the summation of vertical force is 0. So, this is the first top sigma v is acting downward. So, 2b is the width into the sigma v, that is the force. Then the weight of this strip, weight of the strip will be 2b into gamma into dz, because this is dz. So, this is dz, okay, into dz. Then this force is acting upward direction. So, this will be minus 2b into sigma v plus del sigma v, and this shear stress that is also acting upward. So, this will be 2 into C plus sigma h tan phi. Why 2? Because it is acting in the both side into dz, okay. It is acting on the dj distance. So, that is equal to 0. So, finally, after simplifying I can write b d dv plus k d sigma v plus k sigma v tan phi dz equal to b dz gamma minus c dz. So, dividing by b dz, we will get d sigma v divided by dz plus k tan phi into sigma v divided by b equal to b dz means gamma minus c by b. Okay. So, this is the expression. So, after solving, so we have the boundary conditions. How many boundary condition is required? Because one boundary condition is required. So, the boundary condition is the sigma v at z equal to 0 is q, because this is the sigma v at z equal to 0 means surface where q is acting. Okay. So, after solving, with the boundary condition, you will get sigma v is equal to q e to the power minus k tan phi z by b plus b k tan phi gamma minus c by b into 1 minus e to the power k minus k tan phi z by b. Okay. So, this is the expression, final expression. So, that amount of stress will now act onto the conduit. Okay. So, this will act on the conduit. So, because that this is the less amount of the stress, or now for different condition, that for the case 1, if your q is equal to 0 and c is greater than 0 or not equal to 0, then your sigma v will be q is 0. So, this part will be 0. So, this will be b by k tan phi gamma minus C by B 1 minus E k tan phi z by B. Okay. Now, case 2, that your q is not equal to 0, C is equal to 0. So, in that case sigma v is B gamma, that is your C is equal to 0. So, this will be B gamma divided by k tan phi, and C part is 0, 1 minus E minus k tan phi z by B, okay, plus q E minus k tan phi z by B. Now, case 3, that your q is equal to 0, C is also equal to 0. Okay. So, in that case sigma v is equal to B gamma k tan phi 1 minus E minus k tan phi z by B. Okay. So, these are the 3 cases we have considered. Okay. So, now I will apply this one in a tunnel through sand. Okay. So, now the next one, if I apply this, the application of this theory, that we have a tunnels through sand. Okay. So, now we have a, if we have a tunnel through sand, suppose this is the tunnel, or the you can use a culvert also. So, if this is the tunnel and this is the base, now we have a embankment on the or the soil above this tunnel. So, and this is, so now what will happen if it is a within the relatively shallow depth. So, what will happen, this is the void, okay, or because this is tunnel, this is void. So, here the soil, this side also the soil. So, the tunnel wall will deform, this wall will deform this side, and this wall will also deform. So, because of deformation, this soil will move. Okay. Okay. So, this there will be a failure plane will occur, or the soil with the failure plane, because it is this wall is under active condition, because it is deformed because of the soil. So, that means we can say there will be a failure or the surface as it is an active condition. So, this will make an angle 45 degree plus phi by 2, and this side also there will be active condition, where this soil, this surface will making an angle 45 degree plus phi by 2. Okay. So, this is the active condition. Because this side is soil and this side also is soil. So, if I, and this surface, if I, so that means this portion of the soil will move. So, this portion of the soil will move. So, that means soil above this portion, this also move. Okay. So, soil above this portion will also move. So, I can write that if this is twice B and this one is 2 B dash. So, I have derived the expression where this is the twice B. So, here this total portion of the soil is moving, here this portion of the soil is moving, because this soil, this wall is deformed and this soil is moved under active condition. As these two parts of soil is moved, this soil also in stationary condition. So, I can write that this case tunnel deform due to the yield of its lateral support. The support will move. this soil is also moving. So, that means this soil is stationary and this soil is yielding. Okay. Here the deformation pattern will be something like this. So, now the stress on this tunnel will be, so this is my case O1. Okay. So, case O1 sigma v stress which is acting on the tunnel will be gamma, because here this is a sand. So, C value is 0 and Q value is also 0. Okay. So, in the case 1 your C value is 0, Q value is also 0. So, if the C value is 0, Q value is 0. So, this is the expression. So, instead of B, because here B I will write twice B, B dash. So, instead of B it will be B dash divided by K into tan phi 1 minus e to the power minus k tan phi z by b dash. Okay. So, you can write this is the, if it is the height. So, instead of this is the z. So, this is the z. If it is h, instead of z you can use the h. So, why this is the 2 b dash. So, now how I can write where, how I can write 2 b dash, 2 b dash will be twice b, because this is the width of this tunnel. So, this will be twice b plus this angle is 45 degree minus phi by 2. Okay. And this height is say h. Okay. This height is h. So, this portion will be, this is h, this is 45 degree minus phi by 2. So, this portion will be h tan 45 degree minus phi by 2, and that will be twice this side and this side. So, 2 b plus twice h tan 45 degree minus phi by 2, or I can write that this is twice b dash. Twice b dash is 2 into b plus h tan 45 degree minus phi by 2. So, this is the application. So, now if these values are given and it is said that you determine the stress acting on the top of the tunnel, then you use this expression and determine the stress acting on the tunnel. Now, in the case 2, where your tunnel is in very deep. Okay. So, suppose this is the ground surface and your tunnel is somewhere here, which is very deep. Again this is the twice b. So, this is the tunnel. So, again this is void the soil. Again here this will be the 45 degree minus 45 degree plus phi plane, and this is also 45 degree plus phi by 2 plane. So, and this soil will deform. Okay. And because of that there will be a stationary soil mass above the tunnel, but as the depth is very large. So, this deformation effect will not reach to the ground surface, because here case 1 it is the shallow depth relatively. So, deformation effect reaches the ground surface, but here it is the depth is very high. So, this deformation effect will not reach the ground surface. So, there will be a point where this deformation will not be there. So, that point is say here. Okay. So, that means here this deform, after that this soil will not deform because of this effect, because it will not go up to the very large depth and it will not reach the ground surface. Okay. So, that means if I say this is the Z1 and this is the Z2. So, now what will happen in this case, this is again the 2 b dash, and 2 b dash I can calculate with this equation. but instead of this now addition force will act is the surcharge. Now, here in this plane, now suppose this is my new ground level and this soil up within the Z2 depth will act as a surcharge. Okay. So, this is the Q which is gamma into Z2. So, now in the case 2, your C is equal to 0, but Q is equal to gamma Z2. So, the sigma V which is act on this the top of the tunnel, that is sigma V is again gamma B dash divided by K tan phi 1 minus E minus K tan phi into this will be the Z1. Okay. This is the Z1 divided by B dash, then plus the Q part, that is gamma Z2 e to the power minus K tan phi, then Z1 divided by B dash. So, you can see that if is the Q is there. So, this is Q e to the power minus K tan phi Z by B. So, this is also Q is gamma into Z2 and e to the power minus K tan phi Z1 and B dash. Okay. And B dash value we will calculate from this same expression. So, these are the two cases I have discussed where you can apply this theory and you can calculate the stresses acting on the tunnel or the conduit. Okay. So, now I will show you few more applications that how you can apply these theories. So, this is the your active and passive arching. So, now the analysis of load on ditch conduit. Okay. So, that means this conduit where I can calculate the stress if this is the B C is the diameter. So, here the same expression we are using that I have developed, but the where mu value is here value is mu. So, this mu is nothing but the tan phi. Okay. So, in my previous expression I have used the so mu is tan phi. So, I have used the tan phi, that is the mu, K is the again your ratio of the lateral earth pressure at the side of the ditch to the average vertical pressure. Okay, that I have mentioned, and this is the B C is the horizontal diameter of the conduit. Okay. And then h is the small h is the distance from the ground surface to any horizontal plane in the backfill. So, if it is up to here, if you want to calculate, then instead of small h you have to use the capital H. H is the any distance below the ground surface. You can see the similar expression they have also derived, that I have derived. So, and if you want to determine the stress acting on this conduit, okay, so then instead of small h it will be the capital H. Other thing B D is the with here, remember that I have used 2 B, here they have used the only B. Okay, that is why the equation is slightly different. Okay. So, but the same way it is been derived, and this is the, so that means here remember that it is not the stress, because my case in the previous case the sigma V which is the stress, but it is the force. Okay. So, now you know you have to multiply it to get the force. So, directly you get the how much force is acting on the conduit. Okay. So, this is one thing. Now, if it is the maximum load on a ditch conduit, in case of very rigid pipe, if the conduit surface is very rich, when the side fields are relatively compressible, then the conduit carry particularly all the loads. As I mentioned, if the side surface are more compressible than the structure or the conduit, then the stress from the surface to come on the soil, on the structure. Okay. So, here it will you will use this chart and then you will use this expression to get the forces. So, this is that means all the forces will be taken by the conduit. Okay, so this is the CD is the coefficient that you will get, H is the and the BD is this width, H is any height. Here what is the, if you this is your H value, calculate what is the H, you know the BD. So, from here depending upon the different types of soil, okay, so you get the CD value from the curve or from the expression also use CD value, then you calculate what is the force or what is the maximum load acting on a ditch conduct. Okay. So, now if it is a flexible conduct, that means your conduct or conduct is more compressible compared to the surrounding soil, then you will be reduction of the stress. So, that means here you can use this expression B c in a CD also you will get from the chart, okay, that I have given. So, now here, so okay, in this question side fields must be compacted, because otherwise because side field must be compacted means they are more rigid or stationary mass, and the soil above the conduct will be a yielding mass or the moving mass. So, that means the stresses will be reduced, it will transfer from the conduct surface to the stationary or the rigid soil. Okay. So, this way you can determine the stresses acting on different types of conduct. Okay. Or so, now, so before I end this course, I am giving the references or the books from where I have taken the materials. I have given in each and every slides or every lecture the references where I have taken the materials. So, these are the books. So, you can see where I have taken the materials and I have used these books for the materials. In addition to these books, I have taken the photographs and I have given the source information below the each and every photographs. I have used some YouTube videos also. I have given the source of those files in the video links. So, all this information you will get, that the video link source, photograph source, even I have given the photo from the book. I have also given the reference which book I have taken the photograph or the figure. Okay. If I am using any table, I am also giving the reference. So, these are the books mainly from where I am taken the material. So, before I finish this course, I want to mention few things, that in the shallow foundation part, the tables for the different bearing capacity theories, Hansen, Basic, Meyerup or the IS code, the table that I am giving, that is that you have to use for in the exam. Okay. So, that I will judge based on those tables and the charts that I have given. So, you have to use those charts only. If you are getting different charts and different tables in various books, but you have to use the tables that is given in this course. Okay. And in the pile foundation, as I mentioned, I have explained how to calculate the bearing capacity of pile based on the critical length concept, with or without. Okay. So, my suggestion, if it is a homogeneous soil, use the critical length concept. If it is a layered soil, sandy, then use the critical depth concept. But if it is a sandy soil, then a clay layer, thick clay layer, again the sandy soil, then better to consider or determine the bearing capacity without considering the critical depth concept. Okay. So, these are the few suggestions that will help you during your exam. So, I wish all of you all the best for the exam. Thank you.